Good morning students, I am your Nagini ma'am. Today I am going to discuss about the abnormal molar masses in simple method. This topic is from solutions lesson students. Okay, so first of all, what is the importance of colligative properties? Colligative properties are used to determine the accurate molecular mass of the solute students, molecular masses of the solute. So the colligative properties gives the accurate molecular masses of the solutes if the following conditions are satisfied. Okay, if the following conditions are satisfied, then the colligative properties gives the accurate molecular masses of the solute students. Clear this one? So colligative properties, colligative properties gives the accurate molecular masses of the solute, accurate molecular masses of solutes. Clear students? If the following conditions are satisfied, if the following conditions are satisfied. Okay, satisfied. So what are the conditions students? Conditions, first one, the solution should be dilute. What is the condition students? First condition, the solution should be dilute. The solution should be dilute. Second condition, the solute should not associate or dissociate in the solution. Okay, na? The solute does not dissociate or associate in the solution. Clear this one students? The solute does not dissociate or associate in the solution. Clear? So these conditions, if they satisfied, then the colligative properties gives the accurate molecular masses of the solute students. Okay na? So we know that the solution should be very dilute. The solute does not dissociate or associate in the solution. If suppose we know that main point students, colligative properties mainly depends on the number of solute particles but not on the nature of the solute particles. Clear this one? What I told students, colligative properties mainly depends on the number of solute particles, number of solute particles, but not on the nature of the solute particles, nature of the solute particles students. Okay, so colligative properties mainly depends on the number of solute particles but not on the nature of the solute particles students. That means if that means here solute does not dissociate or associate in the solution. Okay, does not dissociate or associate in the solution. If suppose the solute undergoes dissociation or association, what will happen students? The number of that means the solute particles, in the number of solute particles there is a changes, then automatically colligative properties also changes students, because the colligative properties mainly depends on the number of solute particles. If the solute undergoes dissociation or association, what will happen? If suppose solute undergoes dissociation, number of solute particles increases, number of particles are increases. If it is undergoing association, number of particles decreases students. Are you following? So number of particles decreases. Then what will happen? There is a changes in the colligative properties. Clear? So because the colligative properties depends on the number of solute particles. Okay, clear this one? If suppose when if the solute undergoes dissociation or association, there is a changes in the number of solute particles. Number of particles there is a changes. Automatically molecular masses also changes. Correct? Molar masses, there is a changes in the molar masses. That's why that is calling as abnormal molar masses. masses. That means there is a changes in the molar masses. When we can observe, students, if the number of if the solute undergoes dissociation or association, then there is a changes in the number of solute particles, then automatically molar masses of the solute also changes. Are you following? This is nothing but abnormal molar masses. Clear this one. If suppose if the solute undergoes dissociation, if the solute undergoes dissociation, what will happen, students? If the solute undergoes dissociation, for example, I am taking NaCl I am taking, it is the solute NaCl. When it is undergoes dissociation, students, that means when it is added to the solvent, it undergoes dissociation, it is split into the ions Na plus and Cl minus. Okay, now NaCl it gives Na plus and Cl minus ions. So that means for every 1 mole of NaCl, this is 1 mole of NaCl, 1 mole of NaCl, there will be 2 moles of particles, correct? Here 1 mole of Na plus, 1 mole of Cl minus. That means 1 mole of NaCl produces 2 moles of the particles. Are you following? So that means number of solute particles increases. Number of particles are increasing. Number of particles increases, automatically colligative property also increases, students. Are you following? Both are directly proportional. So colligative property also increases, students. Okay. Colligative property increases. So what we can say that 1 mole of NaCl produces 2 moles of particles. Clear this one? 2 moles of particles. Here 1 mole, here 1 mole, total 2 moles. 2 moles of particles. Clear this one? Now see, students, 1 mole of NaCl produces 2 moles of particles. Okay. Then here what is the observed colligative property, students? Here theoretical colligative property, observed colligative property will be there. So theoretical property is, it is a fixed value, students. Theoretical. Observed, what we observe from this equation, that is the observed colligative property. So observed colligative property, here number of moles, 2 moles increases. We are taking 1 mole, but how many increases if it is undergoes dissociation? If the solute undergoes dissociation in the solvent, then it produces 2 moles of particles. That means number of moles increases. So that's a colligative property. Observed colligative property it will be twice the theoretical colligative property. Clear this one? Theoretical value. So what we can tell students? Observed colligative property, observed colligative property will be twice the observed colligative property. This is twice kada, 1 plus 1 2 moles. That means here 1 mole you are taking 2 moles. That means twice will be twice the theoretical value. Clear this one? Theoretical value. Understood, Amma? Will be twice the theoretical value. Okay. Next, coming to the molar mass. So we know that the molar mass of the solute is inversely proportional to the colligative property. It is inversely proportional. Colligative property increases, molar mass of the solute decreases, students. Here molar mass is this one is, it is 1 mole. This is 1 plus 1 2 moles kada. Here molar mass, if suppose if I take 2, it is 1 mole kada. That means it will become half of. Are you following? This is suppose this is x mole I am taking. This is the x molecular mass. Then what will happen? It is x by 2, this is x by 2. Then you will get the x mole. Are you following? This is half, this is half. This is 1 mole kada. So that means their molecular mass will become half of. This is half, this is half. Total value, this is 1 mole. Are you following? 1 mole weight. So that means here we can say that the mass of the molar mass of the solute, the molar mass of the solute inversely proportional to the is inversely proportional to the colligative property, students. It is inversely proportional to the colligative property. Understood, Amma? So the molar mass of the solute is inversely proportional to the colligative property. So colligative property will be twice, observed colligative property will be twice the theoretical value. The molar mass of the solute is inversely proportional to the colligative property. Colligative property becomes twice. Then what is the then what about the molecular mass, students? It is inversely proportional kada, it will be decreases. That means the observed molecular mass will be half the theoretical value. Are you following, students? If suppose I am taking here, this is its molecular mass is x, then these ions masses, nana, sodium and chlorine masses are half of then this is x I am taking, this is x by 2, this is x by 2, because equal number of moles kada. So that's why I am taking this molar mass is x by 2, this molar mass is x by 2, half of you will take, then you will get again x mole. So that means that here what will happen, x mole will become half of. Are you following? That x grams of weight, it becomes x by 2. So that's why each ion weight is x by 2, that means half, it will become half. Understanding? So the observed molecular mass will be half the theoretical value. Are you understanding, students? The observed molar mass will be half the theoretical value. Clear, Nana? Will be half the theoretical value, students. Okay, so this is if the solute undergoes dissociation, this is the case. Are you following? So when it undergoes dissociation, number of particles increases. Means colligative properties increases. So the 1 mole gives 2 moles, so that's why number of moles increases. We know that colligative property depends on number of solute particles. Number of solute particles increases, that's why colligative property increases. So observed colligative property will be twice. Here 1 mole, here 2 moles, that means double happened. So observed colligative property will be twice, because number of moles increases. That's why what will happen, number of moles of the solute increases, the observed colligative property will be twice the theoretical value. Are you following? It is 1 mole kada, it will be twice the theoretical value. And next, the molar mass of the solute is inversely proportional to the colligative property, students. This is the point you have to remember. The observed molar mass will be half the theoretical value. Okay. Next, if the solute undergoes association. Okay, second case, students, if the solute undergoes association. Okay, what will happen? If the solute undergoes association, the number of solute particles decreases, students. Okay, for example, I am taking the benzoic acid, C6H5 COOH. This is benzoic acid. It produces half mole of C6H5COOH. It is 2 molecules. Okay, twice. That means it is a dimer of benzoic acid. Correct? It is a dimer. Understood, students? It is a dimer of benzoic acid. So it is a dimer of benzoic acid. Now see, students, here I am taking 1 mole, but here how many moles came? 1 by 2, half mole only came. That means number of moles decreases. Are you following? So when the solute, this is benzoic acid, this solute, when it is undergoing this association, that means it is when it is dissolved in the solvent, if it is undergoes association, what will happen, students? It produces a dimer. Okay, na dimer. That means here benzoic acid, 1 more, it is combined with benzoic acid, produces, it is a dimer of benzoic acid. Clear this one, dimer. Now coming to the number of moles, we have to see only when we are taking the colligative properties, you have to consider only number of moles. This is 1 mole, this is half mole, correct? So here we can say that 1 mole of benzoic acid, okay, produces half mole of dimer. Are you following? That means number of moles, how much, students? Half mole. That here 1 mole kada, here 1 mole, here it will become half. That means number of moles of these particles decreases. Are you following? The number of particles decreases. Are you understanding? So number of particles decreases. Understood, Amma? Number of particles decreases. Number of particles decreases, what will happen, students? Number of particles decreases, colligative properties also decreases. Colligative properties also decreases, students. Understood, Nana? So the number of particles decreases, colligative properties also decreases. So that's what we can say. Observed colligative, this is the observed. Now what we are observing, half mole happened, 1 mole becomes half mole. Okay, now so this is the observed number of particles. So observed colligative property will be half the theoretical value. Are you following? Theoretical is 1 mole, but here we are getting half mole. Are you following? So what we can write, students, here? Observed colligative property. The observed colligative property will be half the theoretical value. Are you following? Theoretical value. So observed colligative property will be half the theoretical value. Theoretical value is 1, but observed colligative property half. It will, because number of moles decreases, half it 1 become half. Okay, now so that's a colligative property also will become half. Okay, now will be half the theoretical value. Are you understanding? Will be half the theoretical value. Now what about the mass, students? See here, this one molecular mass is, suppose x I am taking. So this is the x mass, and this is dimer kada. So then what will happen here? 2 molecules are there. So that's why here what you will get, 2 into x. What is its mass? 2x. Are you following? This is the x grams. Now this is the 2x grams. Are you understanding? That means what happened? Molecular mass will become doubled. Molecular mass is becomes doubled. That means the observed molecular mass will be twice the theoretical value. Are you following, students? So the observed molecular mass will be twice the theoretical value. X becomes twice. Are you following? So that means what we can write, students? The observed molecular mass will be twice the theoretical value. Clear? This one will be twice the theoretical value. Understood, Nana? So the observed colligative property mainly depends on the number of solute particles. So here 1 mole of the particles, if you take half mole, it becomes half mole. That means number of particles decreases, it becomes half. That's when number of particles decreases, colligative properties also decreases. That means observed colligative property will be half the theoretical value. Okay, now the observed molecular mass, this molecular mass, if suppose it is in x grams, this mass is, it is 2 molecules kada. You should not take number of moles, students, only molecules you consider. This molecule is x grams, this one is how much, students? 2x grams. That means molecular mass will become double. Understanding? So it will become twice. So the observed molecular mass is twice, it will be twice the theoretical value. Are you understanding, students? Twice the theoretical value. So this, when it is happens, students, if the solute undergoes association or dissociation, then what happens? There is a changes in the molecular masses. Are you following? So before, suppose if the solute undergoes association, the molecular mass is increases. Molecular mass of the solute increases. That means molecular mass increases means what will happen? There is a changes in the colligative properties. There is a changes in the molecular masses. So that's why that only will call it as abnormal molecular mass. Are you following? In the case of dissociation, what will happen? Molecular mass decreases, it will become half. Okay, now in this case association, molecular mass will become twice. Are you understanding? Observed molecular mass will be twice. In the case of dissociation, molecular mass will be half the theoretical value. Are you following, students? So this is the abnormal molecular mass. So that's why the solute should not undergo dissociate or association in the solution, students. Are you following? That means the solute does not react with the solvent. It should not undergo dissociation or association in the solution. Okay, now if it is undergoes dissociation or association, what will happen? There is a changes in the molecular mass, number of moles of the solute, there is a changes, and colligative properties changes, molar mass also changes. That's why it is calling as abnormal molecular mass. Okay, students, I hope you like this video. Thank you, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you.